In Lesson 2.7, we'll learn how to write proofs involving segment addition and write proofs involving segment congruence. How can segment relationships be used for travel? When leaving San Diego, the pilot said the flight would be about 360 miles to Phoenix before continuing on to Dallas. When the plane left Phoenix, the pilot said the flight would be about 1,070 miles. If you wanted to find the total distance, you could add 360 plus 1,070, and you'd get a total distance of 1,430 miles. They numbered the ruler postulate 2.8 in this textbook. The ruler postulate states the points on any line or line segment can be paired with real numbers so that given any 2 points, A and B on a line, A corresponds to 0 and B corresponds to a positive real number. The postulate number 2.9 in this book is the segment addition postulate. It states if B is between A and C, then AB plus BC equals AC. If AB plus BC equals AC, then B is between A and C. That's the converse of the original statement. And we remember in general the definition of between is that B is between A and C if A, B, and C are collinear and AB plus BC equals AC. Prove the following. Given PR is equal in length to QS, prove that PQ equals RS. It's always nice to mark what you know on your diagram, so you want to draw the diagram on your paper. Okay, so they told us that PQ, PR, is equal in length to QS. Okay, I'm kind of writing all over the top of it. And we want to prove that PQ is equal in length to RS. Well, it looks like if we can just take out that QR segment in the middle, what we'll have left should be equal. Good plan. Always a good idea to start with the given. So we've got PR equals QS given. Woo, we've begun. So we can subtract equal amounts from both sides. So we're subtracting out that QR from both sides. And by the segment addition postulate, if we subtract the parts, what we have left is going to be PQ on the left and RS on the right. So we've got, by substitution, PQ is equal in length to RS. So we just wrote out in a formal two-pronged proof what we said when we scribbled all over the diagram. Congruence of segments is reflexive, symmetric, and transitive. So we could use the reflexive property to say segment AB is congruent to segment AB, symmetric property if AB is congruent to CD, then CD is congruent to AB, and transitive if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. We can use those properties for the following proof. We are given that WX is congruent or equal in length to YZ, so they've marked that. And YZ is congruent to XZ, they've marked that. And XZ is congruent to YW. Prove that WX is congruent to YW. Well, you look at the diagram and yep, sure enough it is. But we've got to write it out, so we've got WX is equal in length to YZ from our given. So that means that the segments are congruent by the definition of congruent segments. We were also given that YZ is congruent to XZ and XZ is congruent to YW. We can use the transitive property now to say that WX, since it's congruent to YZ, YZ is congruent to XZ, it must be congruent to XZ. And still using that given from step 3 there, if WX is congruent to XZ, XZ is congruent to YW, so now WX is congruent to YW by the transitive property again. We use properties of equality and congruence to write proofs involving segments.